Hi, this is Stefan Bayer with part 3 of my video series on blockchain security. So in this episode, I want to look quickly at off-chain code and infrastructure issue that might be involved in blockchain security. So yeah, let's just get started. So what is off-chain code? Well, in terms of blockchain application, it's actually most of it. The actual smart contracts or assets on the blockchain are a very small percentage of the code base. But there's a lot of other code involved, and there's databases, websites, user interfaces, which we basically need to interact with smart contracts. There's key management code, which is very important, how to deal with private and public keys. And there's APIs that might be exposed. So all this is sort of traditional cybersecurity, which obviously shares the traditional risks of off-chain code. There's nothing specific to this, with the exception of maybe key management, which is also present in non-blockchain applications sometimes, but it's obviously a very important part of blockchain applications. But anyway, this is traditional cybersecurity. There's nothing there that only happens on blockchains, which in contrast to smart contracts, where there are blockchain specific issues. But here it's just traditional cybersecurity. So common incidents there at the application level, code level, might be unsecure authentication. Users might connect that are not supposed to connect, or might have different privileges than is expected for them. Often there's some erroneous use of cryptography. Now, cryptography is great, but it's fairly difficult to get right. People might use the wrong settings in their libraries. Low-level libraries, OpenSSL, for example, allow quite absurd parameter combinations, which are fairly insecure, because they're very general purpose, and not just in blockchain applications. In general computing, people get cryptography exceptionally wrong quite frequently, and that's because it's hard to do. So key storage might be exposed. Private keys are often leaked. I've even seen keys leaked onto GitHub when people publish their source code and forget to exclude their private keys from being published. The software we use might have vulnerabilities. Often cryptographic libraries use secure algorithms in a poor implementation. That can happen. There's also less severe but still important vulnerabilities in all types of software that is usually involved in a complex application. And last but not least, there might even be backdoors. Some employee that left the company might have left a backdoor there to get back in, and that applies to all sorts of software that we reuse. Usually we build on quite a lot of software built by other people, maybe open source software, and there might be backdoors in there. So again, very difficult to trust the whole code stack, and that was just a list of things that might go wrong, but there are many more, of course. Now, the same is true for infrastructure. Every blockchain needs to run on some infrastructure. If you run a blockchain node yourself, you probably use some sort of node software, client software that you connect to the network. That needs to run an operating system. The node software itself needs to be secure. The operating system might have security vulnerabilities. You're probably connected to some network. That network might be configured poorly. You might have APIs that are exposed. This happens quite often. And permissions can be wrong. So again, here are things that can happen. So as I've already said, the node software itself might have a vulnerability. That has happened a lot in the past. Ethereum clients, Bitcoin clients have had vulnerabilities, software bugs that could be exploited if not updated. At the operating system level, there might be insecurities or vulnerabilities. The network might be attacked, might be configured poorly. A denial of service attack is quite common, where a node might even be isolated from the rest of the blockchain. That's usually called an eclipse attack. This attack consists in isolating a node that it cannot see the rest of the blockchain and then just operates on its local copy. So that way you can get some double spending going relatively easily. Obviously, only if the node doesn't realize that it's been eclipsed, or your software that builds on the node doesn't take this into account. Very common use is to leave APIs open to the world that shouldn't be. An example of this is the JSON RPC port on Ethereum nodes, which is sometimes left open accidentally. And there are a number of bots just sweeping the network, waiting for Ethereum nodes to come online with that port open, and then funds are gone relatively quickly. Very common security incident. So what's the solution to all this? Well, I said at the end of the smart contract video to get a smart contract audit. And to be honest, most companies or serious projects have taken this on board by now. Smart contract audits are very common, and they're often required. If you want to get your token onto an exchange, they usually ask for a number of audit reports. But people tend to forget the rest of the stack. And so that's why I recommend here to get a full stack security audit. Don't just look at the smart contracts. Look at what you would look at in a normal software application. And given the risks involved with digital assets being accessible, look at it even more closely. Get a full stack security audit for blockchain applications. And that's all for now.